Hey guys, and welcome back. Today we're going to be talking about something called the y-intercept. So let's take a look at our learning target. Our learning target today, we're going to compare rates of change. Okay, so rate of change is still very prominent in what we're learning, and initial values. We're going to be talking about what that means, initial value, and how to identify it. We're also going to be able to interpret their meaning and context. But today, in order to get to that full learning target, we're going to first identify y-intercept from a graph, equation, words, or a table. Secondly, we still need to be able to identify the slope or the rate of change from an equation. Really, we should be able to identify the slope or rate of change from an equation, graph, table, or words as well, but we're going to focus on an equation today. So let's take a look at the key concept. It says the y-intercept of a graph is the y value at which the graph crosses the y-axis. So when we look at these different pictures, you should be able to see where the blue line crosses the y-axis. Now remember, the y-axis is the up and down axis. So we're looking for where it crosses the vertical axis, which this first one, I can see that the y-intercept is 0. Okay, because it crosses the y-axis at the value 0. If I look at the second example here, that's this position where the blue line crosses the axis, which there it's up at 4, which you may see some graphs that look like this, where it's scaled in a way where they don't label everything. So this one would be 1, this is 2, 3, and 4. So make sure you can identify which grid line the blue line is actually intersecting. So there we can identify the y-intercept as 4. Now when we look at the third graph, you should be able to see that the y-intercept is at -3, because again, here's the y-axis. If we look to where the blue line intersects the y-axis, there's your y-intercept at -1, 2, 3. Now, I like to think of y-intercept in relation to football, because an interception in football is where the defense intercepts or takes the ball away from the offense. So think about the y-axis as being like the defense, and it is intercepting the ball that's being thrown across this line. So let's take a look at your first example. All right, so it says graph the equation y equals x plus 3. What is the y-intercept of the equation? So let's do this first part here, graphing the line y equals x plus 3. That's the first thing we have to do. Then we're going to identify the y-intercept. So two-part problem here. So far, when we've been creating graphs, the first thing I said we need to be doing is creating a table. Now, when we create the table, as I've shown you in previous lessons, you can pick whatever x's you want, but the y's have to be based on what the x's are. So from the look of my graph, it looks like I can pick anything between -8 and 8. So I'm just going to go with small numbers. Let's try 0, 1, 2, 3. Okay, small numbers are nice because they're easy to compute. Now this equation says that in order to get your output, y, you need to take your x and not multiply, but add 3 to it. So what is 0 plus 3? That would be 3. What is 1 plus 3? That would be 4. What's 2 plus 3? 5. What is 3 plus 3? 6. So that's me taking all of my inputs, my x's, and adding 3 to them, because that's what the equation says to do. Okay, we had a lot of trouble on our last test making sure we created tables according to what the equation said to do. This is our function rule. It's a rule that x and y follow in this specific situation. So now I can actually plot the points. So I have 0, 3, and 1, 4. Let's plot those down. 0, 3 is right here. 1, 4 is right there. Now, technically, you don't have to plot all the points in a table that you create. In order to create a line, all you really need are 2 points. And the rest of the points should lie on that line. So try to draw your line as straight as possible. Okay, if you need, use a ruler and make sure you extend the line. Okay, a lot of times I'm seeing students not extend their lines to the end of the graph, okay, and put arrowheads on each side. Okay, that will tell me that the line goes on forever. One of my biggest pet peeves is when students do this little tiny guy. Okay, stretch the graph all the way across, just like that. Okay, so now we need to identify what the y-intercept is. Well, where does this graph cross the y-axis? Crosses the y-axis right there at 3. So my y-intercept, and I will usually abbreviate y-intercept as y-int with that dash in between so it doesn't look like yint. And my y-intercept is 3. So the graph is part of my solution and the actual answer of what the y-intercept is part of my solution. If you notice, in our table, the y-intercept is the same as when x is equal to 0. Okay, so the idea here is whenever in a table you see that x is equal to 0, the y value is your y-intercept. So that 3 right there is indicating what our y-intercept is. Let's have you try this on your U-Try. Alright, so let's look at another example. This one says for each graph or the graph of each equation, find the y-intercept. So graphs are pretty easy now that we've looked at the first example. So let's identify where the blue line hits the y-axis. So here I can tell right there at -2, that's where the blue line crosses the y-axis. So the y-intercept is going to be -2. Again, I'm going to do this on the next graph. I'm going to look for where the blue line crosses the y-axis, which is right there, which is now at +2. So the y-intercept is +2. Now, in order to identify the y-intercept in an equation, first remember we had the form y equals mx. Well, now we're going to get into actually looking at that plus b portion that I mentioned. And we're going to talk a little more about this tomorrow, but we're going to focus on that b being the y-intercept. Okay, b is that y-intercept. So all I'm really doing in this equation is looking at that number that does not have the x attached to it. Okay, so and make sure you say the sign that's sitting next to it as well. So the y-intercept in C is -3. We can do the same thing in part D. Again, locate the number that does not have the x attached to it. So here, the number that doesn't have the x multiplying it is +3. So my y-intercept is +3. So now I want you guys to give this a shot in your U-Try. Identify the y-intercept in the equation, and then also, I want you to find the rate of change in the equation above, just to make sure to refresh your memory, and then also find the y-intercept of the graph below. All right, so for our last example, we're going to look at a real-life problem. It says the line models the total amount of snow on the ground during a snowstorm. What is the y-intercept of the line? What does the y-intercept represent? What is the slope of the line? What does the slope represent? So let's first focus on this paragraph regarding the y-intercept. Let's take a look at where the line intersects the y-axis. Here's the y-axis. So where the line crosses the y-axis is right here at 3. So the y-intercept of the line is 3. What does the y-intercept represent? Well, let's take a look at what the axes are titled. So I have on the y-axis, the title is the snow height. Now what this point is 0, 3. So the 0 is what the x is, and that's hours. So when no hours pass, okay, at hour 0, or at the start of when we started recording the snowstorm, we had 3, it looks like, inches of snow. Okay, so I'm going to write the representation out. The y-intercept, and please write this down because part of these math lessons are being able to write out your ideas. So the y-intercept represents at the start, it's important that we say start, at the start of the storm or snowstorm, there was 3 inches of snow already on the ground. Or we could just say 3 inches of snow. Okay, so at the start of the storm, there was already 3 inches of snow. So now let's take a look at the slope. Okay, the slope of this line, remember, is just the rise over the run. So I'm going to go from point to point and look at what my rise and my run is. So the triangle that I just highlighted has a rise of 1 and a run of 2. So the slope is equal to 1 over 2. Well, what does that represent? The rise is the y's. So what this represents is the slope represents for every 1 inch of snow fallen. Okay, because that's what the rise is. It's the title of the y. Okay, so I referenced the snow fallen, the inches of snow fallen. So the slope represents for every 1 inch of snow fallen that 2 hours go by. Okay, so I described the rise and the run in my representation just by reading the titles of the axes. So I've identified my y-intercept as 3. I've identified my slope as 1 over 2. And then I also made written explanations as to what they represent. So I want you guys to give this a try in your U-Try. All right, so just to sum up, our learning target for today was to compare rates of change in initial values and interpret their meanings in context. We haven't quite covered all of that learning target yet, but we will be getting there throughout the next couple days. The success criteria that we had today was we were able to identify the y-intercept from a graph. We had that, an equation, words, or a table. Okay, you can look at any of the 3 examples and see any of those different things. We also were refreshed on how to find slope or rate of change from an equation. We also looked at it in a graph as well. So let me know if you guys have any questions or confusions, and you may go ahead and start your practice.